Introduction to Statistical Learning in R, and we're in Chapter 7 right here. And I think that this is, yeah, okay. Okay, so we are using the wage data set. And previously, I think either in the chapter or in previous questions, yeah, in question 6, we used, I'll just go up to question 6. We used, what did we use here? Age to try to predict wage, okay? And now we're going to try some different variables, all right? And create, well, that's what we're going to do. We're going to try some of the nonlinear fitting techniques that we've learned in this chapter to use to predict wage given some other variables, and the text suggests a couple here, okay? So let's go through this. All right, so the first thing we need to do is to load the ISLR2 package and get our data up, and that's what I've done here. And I'm looking at all of the different variables that we could look at. And the first thing I noticed is that we could probably chunk these different variables into categories, okay? And so some of these are what we'll call ordered categorical variables, like education, right? There, so we can have, well, I'll just go up here. So we can have, okay, less than high school, we can graduate high school, we can attend college, we can graduate college, and we can have an advanced degree, okay? So there's an order to the different values of education. And then similarly for health. Health just has 2 levels, you know, so we can be in good or poor health, basically, but there's definitely an order there as well. Okay, so next is unordered categories that I have here. Now, one of these is, I think this is marital status. Where are we? Okay, never married, you know, married, but and I've lumped it here into unordered categories. This is maybe a little bit of a subjective call here, because I guess, you know, for you to have been married, that is somehow more advanced than having never been married. And if you're divorced, you have to have been married, and so on and so forth. But I think as it relates to wage, I am just guessing that it is to be treated as an unordered category. And other ones are like job class, race, region, etc. And then finally, numeric, okay? And so there's like the year, you know, we can take year as like time, okay? So that's numeric. And log wage, and we're just going to ignore log wage because it's just the log of the outcome. So of course, you know, has a very strong relationship. Okay. So we're going to look at each of these types of variables here, but we're going to ignore numeric variables because we already did that in question 6 when we used age. Okay, I've omitted age here because I guess I'm just well, I guess I forgot to put it in there, to be honest, but, you know, age would be one of these. Okay. So the first that we'll look at is these unordered categories, and I would submit that we really should not use any of the categories, or it, you know, might not make a lot of sense to use the methods that we've learned here to try to use unordered categories as our predictor variables. We could do it, and there might be times where we would want to do it, but there isn't really a how do I want to say, it's like a continuous relationship between, say, being in the northeast versus the southwest or something, right, with region, right? And so these so that's why we might not want to use the methods that we've learned here with unordered categories. Now, again, notice that the question suggests that maybe we use marital status or job class, and I've put those both as unordered, which may or may not make sense. Again, it depends on, I guess, what you think the relationship between marital status and wage is. And then similarly for job class, there's two levels. There's industrial and I don't remember. In fact, I'll let's just look it up real quick. Uh, oh, okay. I guess we don't have a data sheet on wage. Okay, so that's okay. Let's use D. Oh, I bet it's capital. There we are. Okay, so job class, job class, job class. Okay, yeah, and so D is information. Okay, whatever information means. Okay. Um, so so I don't see how there is I can't see how one is greater than or less than the other in this case. So um, okay, so anyway, so let's move on to ordered categories. Okay, so now ordered categories are different, right? There is really a sense in which high school, having less high school, or having not graduated high school is less education than having graduated high school. Okay, that actually, that order makes sense. Um, so, so that's what we're going to use. We're going to use education, right? Because there's a very clear order in which you obtain education. All right. So so the first method that I'm going to try here, so first I'm going to create this new variable called education int as integer, where I'm converting the education variable, which is a factor, into a number. Okay, 1, 2, 3, 4, 5. Okay, and then I am just going to regress wage on my different levels of this integer value right here. Okay. With the cut function, just like we did in question 6. And I plot all of that, and this is what I get right here, right? So it seems like as we go from from no high school to graduating high school to some college, there's kind of this, looks like pretty linear here, maybe an uptick in the slope here, and then a pretty noticeable slope from going from college degree to advanced degree. Okay, so that's fine. Now, one thing that we might not like about this representation is that it's treating education discretely, right? Because surely going from high school graduation to some college could be anything from like a day of college to almost graduating, but then something comes up and you don't graduate for whatever reason, even though you're a highly qualified student, etc. Okay, so we might not particularly like the idea of treating this as discrete steps, and so we might instead want to use something that is more suitable for like a continuous variable. So even though, again, even though we have education here being a discrete variable, we might want something that represents it more as a continuous variable. And so for that, we could use splines. Okay, and so that's what I'm using here. I'm just using the splines package and then creating some splines with knots 2, 3, and 4, right? So I have a knot here, here, and here. Okay, and then I just plot that, and we get more or less the same thing. But we might want to get creative with this and actually kind of alter our data a little bit so that it actually represents or follows some kind of continuous distribution. Okay, so you'd have to be pretty careful about how you did this and very thoughtful, and maybe even test several ways of modifying the data for this. Okay, but I'm just kind of doing it a little bit slapdash here. But what I'm going to do is I'm going to add some half Gaussian noise to this data, right? And so, well, you'll see what that does, but then I'll just basically run the same model on that adjusted data. Okay, and so when I do that, so notice what I've done at each discrete education level, I've used half Gaussian noise to kind of push data over to the right, where most of the data stays at that particular for high school graduation, most of it stays right at high school graduation. So most people with high school graduation only have a high school graduation and didn't attend college, but some attended some people attended some college and so on, and some got really, really close to graduating but didn't graduate for this reason or another. Okay, and you can kind of look at the code to see how I've done this. again, how I've implemented this data adjustment, you'd really want to, well, okay, so I've done some things to make sure that, that high school graduation data couldn't leak over into the some college data, and but you might think of different models. You might think that most high school graduates have some college, and so you might adjust the mean of the Gaussian noise from being 0, to like a half or something like that, right? So anyway, um, and you might also want to do this many, many times, and then take the average over all of these simulations to get a very good representation, or at least a robust representation. Okay. Now, the last thing that I'll do here is something that isn't addressed in the book, but it's kind of like polynomial regression, and so that's what we'll do here. I don't see this method used very often, and maybe for good reason. It's hard to interpret, but maybe we'll just kind of go through it anyway. So what we're going to do is we're going to keep education as an ordered variable. So now I'm changing, I'm creating a new variable that I'm called eduord for an ordered variable. Okay. And so this just turns it into a factor, but it assumes that the levels have an order. Okay. And then I'm going to regress on that variable, and then let's look at the summary. Now, the summary, these are the coefficients that you get. Okay, so this is a little bit, okay, what's going on here? So you have a .L, .Q, .C, and then caret 4. Okay, so what this has done, what R has done, is taken my ordered variable and then created basically polynomial terms for educational ordered, where the L is the linear, right? So it has, its exponent is 1, quadratic exponent is 2, cubic exponent is 3, and then up to the 4th. Okay, and so this is, I don't want to say partitioned, but I'm going to say partitioned. So now we have, we've partitioned over 5 levels by having 4, basically cut points or something like that. Okay, and further, what R has done is, in fact, maybe I'll just show this really quick. Oops, model matrix M. Okay, so what R has done is okay. So these are the predictor values. Okay, or how do I want to say this? It's created for each observation values for each of these variables that it's created, and each of these columns here are orthogonal to one another. Okay, if that doesn't make sense to you, it's not really important here. I guess all that you need to know is that R has chunked up it's taken my ordered variable, created one variable with it, and then raised it to different powers, basically. So it's kind of like polynomial regression. That's what's gone on here. Okay, and so then with this, again, we can go through and we can run the same kind of analysis where we have our different levels of education and the fitted values, the predicted values of obtaining different levels of education, and you see that it's very, very similar to the other methods that we've used. Okay, we'll call that good.